Tonight we're here for the 9th Dennis Anderson Lecture, which is the college's flagship lecture on annual policy, on energy policy. It's a collaboration between the Energy Futures Lab and the Imperial Centre for Energy Policy and Technology. The Energy Future Lab itself was founded in 2005 to develop multidisciplinary research across the college, really bringing together the many disparate academics and disciplines who have something interesting and relevant to say about energy. It is one of our 6 Global Challenge Institutes. So from a college point of view, it's an important investment, and it's an important bit of our multidisciplinary research landscape. This series is run in commemoration of the huge contribution to the energy environment debate provided by Dennis Anderson. He was a professor of engineering and environment here at the college and founder of the Imperial Centre for Energy Policy and Technology. Dennis came to Imperial after a distinguished career at Shell, the World Bank, UK power industry, and the former Energy Ministry. In 1998, Dennis foresaw the need to bring together a number of different disciplines to help tackle and challenge the key areas that are associated with energy, which is a very foresightful and wise thing to have done. And the Energy Future Lab is the corresponding embodiment of that vision and that lab going into the future. Whilst at Imperial, Dennis made many notable contributions to the UK energy policy, not least his substantial role on the Stern Review on the economics of climate change, which led to the landmark 2008 Climate Change Act. So in terms of, that's the history and the context. If we now think about tonight's lecture, which is on the topic of whether energy and climate policy is the science of necessity or the art of the possible, as you can see from behind us. Our speaker is Professor Jim Skea, and he's very well placed to provide insights into this issue. Jim is currently the co-chair of the Working Group 3 of the Intergovernmental Panel on Climate Change, Ipcc, so a very influential body producing reports on state-of-the-art and mitigation in this really important area. Jim has been a professor of sustainable energy at Imperial College since 2009 and held senior roles at the UK Energy Research Centre, the Policy Studies Institute, and the UK Energy Institute. So he has a fantastic pedigree and background. Jim has always operated at the interface between policy making, and business throughout his career, and has a CBE for services to sustainable energy and an OBE for services to sustainable transport. So 2 national awards is a very impressive achievement, Jim. I'm sure his wealth of experience and expertise will come to the fore as Jim takes us through a journey of how we can possibly achieve deep cuts in carbon emissions, hopefully achieving net zero by the middle of this century. Jim Skea, everyone. Thank you.
Okay, thanks very much, Nick. And just to say it's an honour to be giving the Dennis Anderson lecture. I knew Dennis quite well when he was here, and he managed to combine rigorous academic research with a career in the public sector and business. He'd been a chief economist at Shell, and he'd worked for the World Bank. So it really is an honour to be giving this lecture. Now, if I can just start with an explanation of the title here. When you're asked to do this kind of thing, the invite usually comes about 3 months in advance, and the inclination is to produce a tremendously pretentious title, which promises a lot, and then with 1 week to go, you suddenly realize you're going to actually have to fulfill that promise. So I have decided actually to pretty much stick to the script on it. So I looked around for where the words possibility and necessity appeared in various places. And the first one I found, necessity. It comes in the Manifesto of Extinction Rebellion, was the place where I really found the word necessity. It's saying what the UK government must do to reach net zero by 2025, a heroic piece of ambition. And by necessity, these demands require mobilization of similar size and scope to those enacted in times of war. So that's a very clear statement, a very heavy statement of the necessity side of the talk. For the possibility end of it, I actually went back to the classics, and it's Otto von Bismarck who noted that politics is the art of the possible, the attainable, the art of the next best. And I'm not sure what Bismarck's approach to climate policy would have been, but I suspect it wouldn't have been the same as Extinction Rebellion. And I have to say that in less extreme ways, these kind of debates are actually reflected in the climate change community. I have colleagues in IPCC who will stand up and say, in the impacts community will stand up, this is what's going wrong with the world, this is what needs to be done, now you engineers go off and fix it for us by getting to net zero. And that may be different from the views of some of us in Working Group 3 of IPCC who have to think through the technologies and the policies of how you actually get there. But just to say what I am going to do, I am going to stick very much to the script. And this talk will be in 3 parts. I'm going to talk about necessity. Second part, I'm going to talk about the possibilities. And in the third part, I will do a grand fudge to try and bring these things together. And when we get to questions, you can ask me whether, if I'm a betting man, I really think we'll be able to keep to 1.5 degrees. So that's roughly the game plan for the talk. Necessity, first of all. Well, we can start, I think, with the Paris Agreement. There was a lot that went before it, but Article 2 of the Paris Agreement talks about limiting global warming to well below 2 degrees and pursuing efforts towards 1.5 degrees, a simple reminder of the long-term temperature goal in the Paris Agreement. Article 4 contains the aim to have global peaking of greenhouse gas emissions as soon as is possible, and to have a balance between anthropogenic emissions and sinks of greenhouse gases in the second half of the century, the so-called net zero aim. So these are the 2 kind of framing things in terms of climate change mitigation that defines the kinds of needs for mitigation policies. Now, because a lot of work previously by IPCC had examined the implications of 2 degrees warming, but there was really no literature out there on 1.5 degrees warming. The Conference of the Parties in Paris also came up with the invitation to IPCC to provide a special report with 2 homework questions. And the first homework question was, what are the impacts of keeping global warming at a 1.5 degrees Celsius level? And secondly, what are the greenhouse gas emission pathways that would be associated with that level of warming? So a 2-part homework question was posed to IPCC by the governments. Now, I have done a zillion versions of the standard presentation of the 1.5 report from IPCC, and I couldn't bear to do it again. So let me just kind of sum up some key points in a few slides, which is defining the kind of needs part of it. So this is a classic IPCC diagram, the so-called burning embers diagram, which looks at different kinds of natural, managed, and human systems and looks at the level of risk to which they're exposed at different degrees of global warming above pre-industrial levels. And the big message is that there is, in fact, a discernible difference in impacts between 1.5 degrees warming and 2 degrees warming. That was not summed up or synthesized effectively before the 1.5 report came up, but it was a very strong conclusion. You can actually see the difference. And I'm not going to go through all of them, but I'll just flag up a couple of the systems to look at. Warm water corals, tropical corals, we can already at current 1 degrees warming above pre-industrial levels see a lot of impacts, a lot of bleaching, a lot of coral death there. And the conclusion is that if we go to 2 degrees warming, we will basically lose the lot, pretty much. But if we are only at 1.5 degrees warming, we might be able to retain a quarter. And that's one of the areas in which the biggest impacts, but difference in impacts. The other one is in the Arctic, and the indicator there is how often do you see an ice-free Arctic emerging during the summer? And the answer is, at 2 degrees warming, you will see an ice-free Arctic about once every decade. At 1.5 degrees warming, you will see it about once every century. So quite a significant difference there. And I could run, these are the most extreme ones, but I could run through each of these kind of systems to explain the kind of differences that are made at 1.5 and 2 degrees warming. Now that, for many people, is the clinching argument about why you must, the necessity of going to 1.5 degrees C. The second question that we were asked was, of course, about the global emission pathways that would be needed to keep global warming below 1.5 degrees. And this blue band, this kind of waterfall, it's very faint to see, but that's the zero line there, effectively, zero emissions. And the graph goes out from 2010 to 2100. And the short conclusion is that CO2 emissions would need, somewhere in the middle of the range of different scenarios, to fall by 45% by 2030 on a path to limiting global warming to 1.5 degrees. Now, I want to make this very clear, this is not advocacy, this is the chemistry and physics. This is from global modelling of the atmosphere. If you want to keep global warming below 1.5 degrees, this is what must be done. And this is a scientific point, it's not a piece of advocacy by scientists. The other thing, in terms of net zero, CO2 emissions need to fall to net zero by the middle of the century, again, to limit global warming to 1.5 degrees. And this is the point basically here. It's a huge, huge range, and we could talk a bit about why the range is so big. But basically, somewhere around 2050, with a bit of a range, CO2 emissions have to reach zero if you are going to keep global warming to 1.5 degrees, which obviously means that by the second half of the 21st century, in most scenarios, you're actually taking carbon dioxide out of the atmosphere rather than putting it in, as we are at the moment. And final point, carbon dioxide isn't the only climate forcer. There are other greenhouse gases. So methane emissions would need to fall. We've got falls in black carbon emissions and declines in nitrous oxide emissions, which are largely from the application of fertilizer in agriculture. So all of these things are consistent with the pathways that are consistent with 1.5 degrees. And just to say again, just to emphasize again, this is a scientific conclusion. It's largely driven by the chemistry and the physics rather than social or economic considerations. So the Paris report, the 1.5 report obviously had a very large impact. Now I'll come on to that in a second. But what I did want to do, and this is the last real picture from the 1.5 report, is to flag up that there is no one pathway in emissions that can keep you below 1.5 degrees. There are different kinds of choices that could be made. And what the authors did was to, from that dirty great blue waterfall diagram that covers a wide range, to pull out 4 specific pathways that illustrate the dynamics of change and the kind of choices that could be made. So in each of these diagrams, the grey area represents emissions from energy and industry. The orange part, which can be positive or negative, are emissions or sinks from agriculture, forestry, and land use. And the yellow part of it, which is extremely controversial, is the use of bioenergy combined with carbon capture and storage to remove carbon dioxide from the atmosphere. And that is where much of the negative emissions come from in the scenarios. Now, just to flag, what this is basically illustrating is that there is a choice between how you could actually keep global warming to 1.5 degrees. This is the most middle-of-the-road scenario in terms of the socioeconomic background. But in a scenario where you have high carbon lifestyles, people eat lots of meat-based products, etc. There's a delay in the fall of emissions, and this needs to be compensated for by a large amount of carbon dioxide removal in the second half of the 21st century. In other scenarios where you reduce emissions more quickly in the short term, the need for carbon dioxide removal declines. And in this case, which is a slightly artificial scenario constructed for the purpose, the use of bioenergy with carbon capture and storage does not exist. It is all managed by other kinds of more nature-based carbon dioxide removal techniques. So that's pretty much as I want to say from the 1.5 degrees report. And just to flag up, that this hasn't been dismissed out of hand by the countries around the world. I know I've been to lots of business kind of conferences, where the reaction to these diagrams is you've got to be joking, quite frankly. But the countries of the world have actually taken this stuff seriously. And I want to move on just to say how countries have reacted to this in the follow-up to the 1.5 report publication. So first, globally, there is something called a carbon neutrality coalition that has been established, where the countries that have signed up are basically committing to the goal and the aim in the Paris Agreement that I showed you right at the beginning. In other words, the well below 2 degrees, the net zero by the middle of the 21st century. And we can pick them out. There is Colombia, where the Ipcc team from Imperial spent the entirety of last week running a lead authors meeting on climate change and land. Costa Rica, Mexico, we seem to skip over a country, and then on to Canada. We've got a number of European countries, mainly Northern European, but also Portugal and Spain. We've got Ethiopia, and just dropping off the edge of the diagram is the Marshall Islands. So 19 countries altogether have signed up to that carbon neutrality coalition. So this is being taken seriously at the kind of the policy level. While we're still a member of the European Union, I can show you this graph, which comes from the Commission, that shows you a document that the Commission published towards the back end of last year, showing how it thinks that the European Union can get to net zero greenhouse gas emissions by 2050. So that is, the net emissions is the dotted red line, and that is obviously, by the time you get to 2050, emissions of mainly non-C2 gases and transport are compensated by measures in the land sector and some carbon removal technologies as well. So that's what the Commission proposed. And I just want to flag up one thing about this diagram, about political constraints, which I'll actually pick up, is that the Commission was constrained by the existing 2030 package that was published on climate change. So you go sort of, modest decreases to relatively modest decreases to 2030, then you fall off a cliff between 2030 to 50 in order to get to that net zero target. And I think one of the themes I'm going to come up with is the question of time consistency in this do it. Waiting too long can cause you lots and lots of difficulties. And finally, just for the UK, I mean, the government asked the Committee on Climate Change to look at the Paris Agreement in 2016, and at the time, the committee said it wasn't quite the time to set a net zero target for the UK. Need to wait for the Ipcc 1.5 report. But at the moment the Ipcc 1.5 report was approved in the beginning of October 2018, Claire Perry, the Minister, along with Scottish and Welsh ministers, wrote to the Committee on Climate Change to request a report on how the UK could get to net zero during the 21st century. And there is a stated intention by government to do that, and a likelihood that the Scottish government will write that net zero into their new climate change bill that is going through Parliament. So things also moving in the UK. And we do indeed expect the Committee on Climate Change to produce the report on net zero. I think it's about the middle of April that it's actually due, and that recommendation will then go to ministers in the UK and the devolved administrations. Now, because this work is underway, we can't really say what's going on. There's a lot of consultation going on, but these are the kind of themes that the Committee on Climate Change is looking for evidence on when it goes through its consideration of how you might get to a net zero target. So that includes the climate science, the Paris Agreement, the global pathways developed by IPCC, international circumstances, current and potential mitigation options, and the costs, risks, and opportunities from setting a tighter long-term target. In other words, what happens to the current 2050 target, which is about 80% at the moment. So these are the things that the Committee on Climate Change is currently working on and will be coming up with a report in the middle of April. Now, I think it's worthwhile remembering as a bridge into the section I'm going to run on possibility that there is a massive gap between countries' aspirations and what is actually happening on the ground, or under the ground even, at the moment. So this is from the annual GAP report, which does what it says on the tin, which is published by the UN Environment Programme. And this is showing, out to 2030, business as usual emissions, the kind of a range of emissions you might expect from the pledges that countries have made under the Paris Agreement, and where you would need to be if you were on pathways for 1.5 or 2 degrees warming. This is the colour of the band makes the difference to these. And it's a very simple message. We've only got about a third of the way from business as usual. The NDCs have taken us about a third of the way by 2030 of where we need to be. So there is much less action on the ground than would actually be needed to fulfill these very high-level ambitions. And what I'm going to do now is to move on to the possibility back at the top. What could you actually achieve? I'll just say, in the 1.5 degrees report, we didn't actually use the word possibility. That rather came from my Bismarck quote at the beginning. But we did use the word feasibility to think about whether this could actually be achieved. And just to say, there was no way we were ever going to produce a report that ticked the box and said feasible, yes or no. Into the political environment we were playing this report, there was no way that either of these boxes, if we ticked them, would have really flown. So what we did was actually break feasibility into 6 different dimensions, or sets of enabling conditions, as they were called, to say, if you were going to get to 1.5 degrees, each of these conditions would need to be met. And so the 6 conditions were the geophysical, in other words, can you do the climate modelling and figure out that it can be done? There was a lot of emphasis on the environmental and ecological, and that's where bioenergy with carbon capture and storage becomes an issue, because large-scale deployment of bioenergy has implications for ecosystem services, biodiversity, and food security, which was what we were talking about a lot in Colombia last week. Do we have the technologies ready? What are the economic conditions that would allow it to happen, that would allow the finance to flow? The socio-cultural conditions, it may be that you would need changes in behaviour and lifestyle if you were going to these very deep reductions in emissions. And finally, more institution and policy. Do we have institutional conditions in place to support transformation? And you could turn that another way around and say it more simply, are the governments and the politicians up for it, would be perhaps another way of putting that last condition. So what we did was effectively to use these 6 conditions as a way of examining the kind of mitigation responses that might be in. I have to say, none of this material is in the standard 1.5 presentation, so I'm delving deeper into the chapters here for this kind of stuff. Some of the stuff I'm about to show you is probably completely unapprovable at a summary for policymakers level. But that's how we went about it. Okay, now this is an excerpt from a very classic Ipcc diagram, and I've got this old joke that says a good diagram can save you 1,000 words, and an Ipcc diagram takes 1,000 words to explain. I've used that one before, and this is a bit in that kind of philosophy. But what the authors of this chapter were doing is to take a different set of mitigation options and against the 6 feasibility conditions, do an estimate of whether there were barriers or enabling conditions for the adoption of these different mitigation options. And the dark brown part of it is saying that basically the conditions are conducive for the take-up of these specific mitigation options. The light brown part says it's neither one nor the other. Some of the indicators are going one way, some of the indicators are going the other. And the light part is indicating that broadly the conditions are acting as barriers to the take-up of these technologies. And so, a very picture, this is the energy sector slide. And basically for the new renewables that are coming in, there is no really fundamental barriers to them coming in. Most of the conditions are positive. Some of them are fairly neutral. Bioenergy has problems around institutional and environmental, and I've mentioned many of the difficulties that large-scale deployment of bioenergy would have for food security and biodiversity, and other issues around the social acceptability of CCS. CCS, carbon capture and storage, is probably relatively acceptable in the UK. It's not necessarily the case in continental Europe, for example. And nuclear energy is seen to have issues around institutional and the social side. And I should say this wasn't the personal opinion of the authors. They were going through underlying literature and counting the number of papers that came to these different conclusions. So that's where these numbers were coming from. They did the same in a variety of different sectors. That's industrial systems, where a theme that's going to come up is broadly very positive around energy efficiency, around technical, institutional sides of it. But the bio-based and the circularity, circular economy is perhaps a bit more challenging in some areas. This is urban systems, which basically covers transport and buildings. And again, just the two themes to pull out of it, a lot of positive features around modal change in transport. So adoption of public transport, pickup of non-motorized transport, all seem to be relatively positive. And the other one is the energy efficiency is also coming up as a very positive, so very feasible kind of options to be taken up. That is land and ecosystem approaches. So a number of areas. This does not include bioenergy with carbon capture and storage, but it's putting up positives around ecosystem restoration and much more controversially issues around dietary shifts as well. This is going to be a really dynamic one to pick up when we produce the special report on climate change and land, because one of the chapters contains a lot in food systems about the prospect for dietary change and its implications for greenhouse gas emissions. And the final one to pick up is more the dedicated carbon dioxide removal techniques. So bioenergy with carbon capture and storage, direct capture, afforestation and deforestation, and especially for these two, potentially a lot of negatives, especially around bioenergy with carbon capture and storage in terms of the feasibility of deployment. Afforestation, deforestation, some positives, some negative. So that's what the authors actually did. Now, one thing that I debated with the authors a bit when we were producing the report is that this feasibility analysis was applied to individual mitigation options, not the overall effort that you would need to put in place. And my personal view, the challenge is not so much all these individual options, because I could see each one of these being deployed somewhere at some time, and in that sense, they're all feasible. The question is, can you combine them and do them in aggregate and do them at the scale and with the speed that you actually need to be compatible with 1.5 degrees warming? So I just wanted to flag up some of the other high-level messages that came out of the report. And it's really very much that scale and speed matter when you're deploying these measures. They may be individually deployable in a particular location, but it's the overall picture that's going to be the challenge. So this is actually from the press release that came out with a report. Limiting global warming to 1.5 would require rapid, far-reaching and unprecedented changes in all aspects of society. And these words were quite well chosen. It really is totally unprecedented zone. We can find nothing in human history that looks like the changes that are associated with keeping global warming to within 1.5 degrees, which is not to say it's impossible, it's saying that it's taking you completely out of the historically defined zone. There was a longer quote in one of the chapters, say there's no historical precedent for the scale of the necessary transitions, but there is some indication that you've actually achieved the required speed in some sectors. Now, what that means, there was one particular area in which we'd identified that the necessary rate of historical transition had taken place. And that was actually in electricity systems. We've seen, in the past, you've seen rapid take-ups of nuclear power, rapid take-ups of natural gas, and at the moment, very rapid take-up of renewable energy. And in electricity systems, you think that you're in the kind of, that possibly in the feasible zone. But we have not seen the speed or the scale of change in any other sector, particularly in the question of decoupling carbon dioxide emissions from economic growth. And more the demand side is easy enough. Well, it's relatively easy when you're looking at a large number of major commercial players that can make big decisions. As long as when you move it into millions or billions of farmers and households, that's when the challenge really becomes up, and we don't have the precedent for actually doing that. So that, for me, is the question of feasibility and how we do it, because many people look at these different pathways and pick out and look at them and look at, are they feasible or not? So the biologists, the ecologists that I was dealing with last week in Colombia look at this one, and they say you've got to be joking because of the scale of the carbon dioxide removal that is associated with that particular scenario. And colleagues in the business sector, if they don't think that's infeasible, they look at that one, and that's where they come in and say you've got to be joking in terms of the speed of change that's implied. And whether there is something in these middle pathways that sort of meets the requirements is, I think, an interesting question. Now, the question I should be answering at the moment is to try to join this all together and say, well, is it possible to do it? Is it possible to do what's necessary? And that's why I said right at the beginning I was going to fudge the answer. But let me explain how I'm going to fudge the answer and how you might go thinking about these kinds of issues. And here I do want to actually think about how the UK's Climate Change Act works and the kind of thought processes and the intentions behind that. So just to remind you, we have an at least 80% reduction target for greenhouse gas emissions by 2050. That's where we started back in 1990, and we've seen reductions of more than 40% already in the UK, which is quite impressive, though much of it driven by electricity. And the trick in the UK has been to say that you have to be consistent over time in the way that you reduce emissions to make it realistic, so that you have these interim steps, the 5 carbon budgets that have been put in place, which we've all complied with so far, though we might have trouble with the 4th and 5th carbon budgets. But that stepped approach and interim targets has seemed to be quite a successful way of bringing things down. So I was on the Committee on Climate Change right from the beginning when the 80% target was proposed by the committee. So how did we go and think about it? Well, we did exactly use the concepts of necessity and possibility to actually do it. Sorry, this is very crude. This is a bridge that we have to bridge, the gap between necessity and possibility. I couldn't find a really good picture of one, so I had to take a kind of PowerPoint shape to get it done. But in terms of necessity, where we started, the analysis said, where is the global danger zone for emissions? And this was done by looking at the scientific literature on the impacts of climate change at different levels. And the conclusion was reached that you needed to have a good chance of keeping global warming below 2 degrees and a very, very, very good chance of keeping it below 4, because there are probabilities involved. Okay, having decided that that was the target, you then look back, what are the global emission pathways that would be needed to to keep global warming within these levels? And I've showed you that kind of analysis already. And broadly, the conclusion was that by 2050, the world would need to reduce its greenhouse gas emissions by about 50% from the current levels. And the final question that was asked in terms of necessity was what would be the UK's fair share of these global emissions. And what was done then was simply to make the heroic statement that you couldn't imagine per capita emissions in the UK being higher than the global average by 2050, so equal per capita emissions by arithmetic and population projections turned into a target for the UK. That was chapter 2 of the first report. Chapter 3 of the first report started at the other end and thinking about what can we possibly achieve in terms of getting emissions down. So we started with expected economic growth and turned that into kind of baseline energy use and carbon dioxide emissions. We then took a look at the existing technologies and those that were foreseeable, those under current development, and added to that kind of business as usual growth. And we set whether this would happen at an acceptable economic cost. And within, I think the numbers at that time were between 1% to 3% of GDP by 2050. We got an answer about what you could achieve. And miraculously, the necessity argument and the possibility argument both got us to around an 80% reduction in greenhouse gas emissions by 2050, which was the kind of the reasoning and the thought processes that we got to the 80% target. Now, the question is, can you use the same kind of reasoning to actually address 1.5 degrees now that the goalposts have actually shifted? So that is the question. And just to remind you, this report that the CCC produced in 2016 concluded that a full and successful rollout of all the options that we'd considered previously, casting aside some of the cost-effectiveness considerations, would allow CO2 emissions to reach zero, net zero, by about 2070, but greenhouse gas emissions in all, including the other gases, would be about 90% below the 1990 levels. So the analysis the CCC did, basically adapting previous analysis, basically said net zero CO2 by about 2070 based on the evidence at the time. But of course, Claire Perry, the Minister, has now asked for a further analysis that has moved the goalpost because the target is net zero could be net zero for everything in the middle of the 21st century. So I think the CCC is working on that analysis at the moment. As I came off the committee at the end of December, I know nothing about what's going on now, which is a disadvantage because I don't know what's going on, but it's an advantage because I can express myself more freely, and now I am out of it. But these are the things that I think governments could do to kind of enable moving in the right direction in terms of change. I mean, first of all, it needs systems thinking. It needs the time consistency that is embodied in the UK's Climate Change Act, where you have interim targets that are realistic on the pathway to a very ambitious long-term target. We should be making early progress by picking low-hanging fruit. And there is an area in which the Committee on Climate Change has picked out government on. I would at the moment. The reversal of successes in energy efficiency policy, where we're installing a fraction of the insulation in residential homes that we were just a few years ago. It's an area in which you've gone backwards. It's one of the cheapest things you could do, so why aren't we picking it up? And we also need to place a value on carbon, I think, to make some of the more ambitious measures happen. So carbon pricing has to be part of the picture. And I'll just flag up, I was at a carbon capture utilisation storage summit in Edinburgh in the I think it was back end of November. And it was striking that all the oil companies were sitting there saying, we need a carbon price in order to get on and help you with carbon capture and storage. 10 years ago, it would have sounded like turkeys voting for Christmas, but the oil companies are now arguing for carbon pricing coming to play a role. I think one other thing, we need to much more acknowledge mitigation opportunities in the land sector. And this does not mean just afforestation, reforestation, avoiding deforestation and BECCS, bioenergy with carbon capture and storage. There are many so-called nature-based solutions that have not been included in the models that have been assessed by Ipcc that won't solve the problem by themselves, but they could make quite an important contribution. We do need to invest in our RD&D for the longer term, because some of the measures we will need to take place in the future are not available now. And not locking in high carbon infrastructure. I would flag up the Committee on Climate Change, I think it was just today, released a report on climate and housing in which it recommended that no house built after about 5 or 6 years' time should be connected to the gas network, because by connecting it to the gas network, you've locked in higher kind of infrastructure. That's an example of the kind of lock-in effects. Perverse incentives, I am immensely struck by the fact that we actually put all of the subsidies on renewable energy and energy efficiency on the electricity price, and at the same time naively expect that heat pumps will take off in the residential market when we've pushed up the electricity price. There is a perversity. There's two parts of climate policy going in the opposite direction. And finally, don't dismiss options on account of short-term practicalities or inconvenience. We do need a bit of everything. And again, for the UK, I would flag up the question of onshore wind, where the policy is being driven by objections, local objections in a small number of areas which are quite legitimate, but are being translated to the national picture, where there are other parts of the country where onshore wind, which is one of the cheapest forms of renewable energy, could actually play. And the bigger questions, I think, that sit there. If you're going to set the longer-term targets at the kind of net zero level, I think there's a big question about how you factor in consumption and behavior patterns into that, which so far very few of the global models are actually doing. And it is probably the case that if you take 1.5 or well below 2 seriously, you need to get into that territory, and we don't necessarily have the analysis or the insight to do that. And finally, UK has been very much, has a system of carbon budgets which are regarded with the kind of, the rigor of a financial accountant coming in and looking at the budget, and you must not overspend them. It's quite strict. One of the things we might think about, and I'd put this out almost for discussion, is whether we do actually make our targets a little more aspirational and leave gaps on them, with the gaps needing to be filled with technologies, measures, or approaches that have yet to be discovered and identified. And when I gave evidence to a select committee recently with Carolyn Lucas from the Green Party on it, that's very much the push. Stretch and then work out later how you can actually achieve the target. Right, so I have talked through necessity, I've thought through possibility. As promised, I have fudged the combination of the two completely. So thank you for your attention, and very happy to take questions and comments.